Okay, we'll review vectors, and we have to just review the notation and what they mean. Then we'll talk about vector addition. We have some helpful characteristics of adding vectors graphically. So let's start with this, and this is a vector. A vector has direction, so this is pointing, we'll say north, and it has a magnitude, so that's the length of the vector. So this vector is representing 30 meters per second north, and now we're going to represent, using that vector, 60 meters per second west. So if we have the grid and we want to go 60 meters per second west, we just have to take that length, which is the magnitude of the vector, and if we went this far west, that's approximately the same length. That would be 30 meters per second west, and we just have to double it, and that represents 60 meters per second west. Alright, so pause the video and try part B, 90 meters per second southeast. And we're just estimating the length. So here we have a length. This length is the magnitude of 30, and we need to have 3 of them going in this direction. If we drew that, that looks like 30 meters per second southeast. And then if we doubled it, now we're at 60, and then we go 3 of them, and that will represent 90 meters per second southeast. You wouldn't put 3 arrows. I'm just showing that we're using 3 of those vectors, and it would actually just be one vector, and that would represent 90 meters per second. So a vectors have direction and magnitude. If there is no direction and there's only magnitude, that's called a scalar. Scalars have magnitude. Alright, try to draw these vectors with about these lengths. And so we'll call this vector A. And we can't just put A, because A is a scalar. We need to do that. So this is the symbol representing that vector. Here, B, that'll be vector B. This is vector C, vector D, vector E, and vector F. Which vectors have the same magnitude, and we just have to estimate. So we look for, if we're looking for magnitude, we just want the same length. So it looks like A and B have the same magnitude, they have opposite directions, and maybe D has the same magnitude. C looks longer, E looks longer, and F looks shorter. So let's say A, B, and D have the same magnitude. You just have to estimate the lengths of these, but you're going to definitely get the right direction. So now we have a graphical representation of vector addition. To get A plus B, we can just draw A, and at the end of A, draw B. So we want A plus B, so I draw A and get about the same length, the same magnitude. And then at the end of A, I'll draw B, so I need about the same magnitude there. And the vector connecting the beginning of A to the end of B is called the resultant, and that is A plus B. Alright, so that is A plus B. Let's try A minus B. And we can write it as A plus negative B. And a negative vector is just going in the opposite direction. So if we copy A again, and then we'll draw B in the opposite direction. So B is going up, and then here B will go down. We have vector A, negative vector B, and the resultant is A plus negative B. Alright, and pause the video, try that one. So for A plus B, we draw vector A, so we need about the same length. And then at the end of A, draw B, so I'll draw that. Vector A, vector B, and there's the resultant, and that's A plus B. Here we have A plus negative B, and we have A coming first, and then we'll add negative B. If B is going to the left, then negative B is going to the right. Negative B, A, and the resultant is A plus negative B. Alright, so 3 different questions. And even here we don't have vectors, it's just a quadrilateral, but we can use vectors to work with, to answer these questions. Alright, so we have A, B, C, and D, and we want to show AB plus BC. What is the resultant of AB plus BC? AB plus BC. So I just draw AB plus BC, and the resultant is AC. And we do have we're going to see a shortcut for all of these. So now you try AD plus DC. Pause the video and go ahead and do the next two problems. Okay, AD plus DC, and the resultant is AC. AD plus DC equals AC. And here we want DC plus CB plus BA. So the start is there and the end is there. That means the resultant of all three of those is DA. And we can say that DC plus CB plus BA equals DA. And so if we look for a pattern, we see what's happening here with these. When you have the same point there and the same point there, we end up just going D to A. So we don't have to draw the pictures if we see that pattern. The same point, so we'll go AC. So there's a shortcut. All right, so we're going to do use the same concept for resultant, but now it's just interpreting or representing this situation. All right, the boat is traveling 20 miles per hour south, and this current is that's just where the water is moving. So we're going to go 20 miles per hour south. So you just choose a length, and we'll say this length is 20, and in the boat, that represents the boat's velocity. And we'd say its speed is 20, but its velocity is 20 miles per hour south. Then, when it hits the current is moving east, so we'll put 5 miles per hour east. The magnitude of this is 5, and the magnitude of that is 20. So the resultant is what we want to find. That'll answer the question. Now we see that it is a right triangle, so we can find the magnitude of the resultant, and that will be the speed. 20 squared plus 5 squared equals c squared square root 425, and we get about 20.6. and that'll be the speed of the boat in the current. To find the angle, we can just look at that triangle and we say that tan theta is 5/20. We'll do inverse tan, and we get 14 degrees, and we just have to describe the direction using that 14 degrees. So we can say the speed of the boat is 20.6 miles per hour, and the direction is moving. One way to describe the direction is you start with south or north, and then you say how far it's moving east or west. So those are bearings, and we'll say it's moving south 14 degrees east. South 14 degrees east. Okay, a boat. So instead of writing it all again, we'll say the boat is moving 10 miles per hour west, and the current is 10 miles per hour north. So do the same problem as before. Find the resultant speed and direction. Pause the video and try that. 10 west, so we'll just say that's 10, and then 10 north, so we'll go the same distance north. We need to find, so the boat is moving west, it hits the current of the same velocity, so now the boat has a velocity vector of this resultant. We need to find the length of that and the direction, describe the direction. So we have 10 and 10 for the speeds, and then we can find the resultant speed. And that'll be 100 plus 100 square root of 200. 14.1 is approximately equal to the length. And then we'll say that tangent of theta is 10/10. Tangent of theta is 10/10. So tangent of theta is 1. And we know that that equals 45 degrees. We can describe the speed. The speed is 14.1 miles per hour, and the direction is, we could describe it as north 45 degrees east, or we could say it's west, or we can say it's west 45 degrees north. Let's just stick with the same. We'll go north 45 degrees west. Alright, and then one more example. So that's going from 1, 4 to 4, 2. That will be vector B. And then we'll go from there to there, and that's vector A. Let's find A plus B, A minus B, B minus A, and 2A minus 3B. All right, and we'll do it graphically and analytically. So for part A, we need to start with A and add B to the end of it. So I draw A, and then we need to take B and draw it at the end. Now B goes down to over 3. 1, 2, 3. So from the end we have to go down to over 3. This is vector A, and that's vector B, and the resultant is that vector. That is A plus B. So that's how we've seen it earlier in the lesson, and we can say that vector is the horizontal component is 1, 2, 3, 4. That's going to be 4, and then it goes up 0. So we can write the vector as 4, 0. We can also write it as 4i plus 0j. And also before we continue, let's look at vector A is the horizontal component is 1, so that's 1i plus 2j. B is the horizontal component is 1, 2, 3, 3i, and this will be minus 2j. Alright, we can do it graphically, or we can just do A plus B is going to be vector A, which is 1, 2. We can write vectors as a column or in terms of I and j, and then vector B is 3 and negative 2, and we just add the horizontal components, add the vertical components. We can do it without a graph or with a graph. Alright, pause the video and try part B. We're doing A minus B. So I start by drawing A, which is, you know what, this gave us the right answer, but I shouldn't have started right there. I need to start at the origin. So we're going to go over 1 up 2, over 1 up 2, and that's A. If you do it this way, it just lets you read the resultant easier. Here we had to actually count because it's 1, 2, 3, 4, 5. It's at 5, but the length we went was only 4, so that's why it would be easier if we just started that at the center. Right, at the origin. So we're going to go A minus B. Now, B is normally going down 2 over 3, so now it has to go the opposite direction. And we're going to have A plus negative B. We need to find out what negative B is and then draw it on the at the end of A. So negative B is going to be negative 3 plus 2. Negative B equals negative 3, 2. So let's see if that looks like it's the opposite direction of B. We're going to go left 3, 1, 2, 3, and then up 2. So we want this. This is negative B. That's positive A. And negative B should be the opposite direction of positive B. And that looks like it is. Now we just draw the resultant. And that will be A plus negative B. We can look at the resultant and say that's negative 2, 1, 2, 3, 4. So that'll be negative 2, 4 is A minus B. And we can also just do it this way. Copy vector A, which is 1, 2. copy vector B, which is 3, negative 2, and I'm just using these from what is given. Vector A is 1, 2, and vector B is negative 3, is 3, negative 2. So now we can just go 1 minus 3, 2 plus 2, and we have the same vector that we got over here. Okay, and we have to do B minus A. So you start by drawing B at the origin and then add the opposite of A at the end. So pause the video and try that one. So I need to draw B from the origin, and B is 3, negative 2. So we go over 3, down 2, there's B, vector B, and then I need the opposite of A. I'm going to go B plus negative A, and A is 1, 2, so we're going to go negative 1, negative 2. Negative A is negative 1, negative 2. So at the end of B, we'll go left 1, down 2. Left 1, down 2. That is negative A, and the resultant is right here. So we can read the components of the resultant by just counting spaces. Over 2, down 4. So we're going to get 2, negative 4 for the resultant, and we know that's going to be B minus A. But we can do it analytically just with A minus B. We copy B, which is 3, negative 2, and then we copy A, which is 1, 2, and 3 minus 1, negative 2 minus 2, so we get the same vector. And the video is getting a little long, so why don't we just do the last one without a graph, and we can just say it's 2, copy vector A is 1, 2, copy vector B. So when we multiply by a scalar, you multiply to both of them. That's going to be 2, 4, and then that'll be 9, negative 6. So 2 minus 9 and 4 plus 6. So that would be 2A minus 3B. All right, we'll stop there.